All right, let's get started. Welcome to the session on Towards an Evolutionary Architecture. My name is Venkat Subramaniam. I'm going to talk about three different things in this presentation. I'll talk about some of the reasons to create evolutionary architecture. I'll talk about some of the things that will make it really hard for us to do and how we can probably overcome it. But then most of the presentation, I'll focus on maybe some of the practices and principles we can follow to create an evolutionary architecture. Best time to ask questions or make comments is when you have it. And if you do have a question, please do draw my attention. It's a little hard for me to see from here where you are. But if you raise your voice and bring my attention, I'll be more than happy to listen to your question or comment. So I want to start with the very first question. What's architecture? Well, that's one of the funny things. If you ask around developers what architecture is, you're probably going to get a fairly long silence. Because architecture is something that we kind of feel what it is, but we cannot put them into words. So we have trouble really describing what architecture is. Well, it turns out we have no real consensus on what architecture is either, because those who will begin to describe what architecture is seem to have different descriptions of what architecture is. I'll draw your attention to one interesting article, which I found to be extremely valuable. And this article is called Who Needs an Architect? And this one is actually an article by Martin Fowler. And this is one that I really like a lot because this article is a very short one, about 3.5 pages long. And he actually takes effort to describe what the real role of a good architect is. I won't spoil the fun for you because when you read it, you will definitely enjoy it as I did. So I won't talk about that part. But one of the things he does in this article is he raises the question of what architecture is. And he goes on to say architecture is those decisions that are really hard to change. And he dislikes the definition as much as a lot of us dislike it, because I can design and create things that are hard to change and then claim that it's architecture. That's not a really good definition after all. But he invites Ralph Johnson to talk about what architecture is. And Ralph Johnson gives a relatively good description of what architecture is. He says an architecture is the set of essential decisions that contributes to shared understanding of a system. And shared understanding is a very important term right there, because architecture is not something that's kind of esoteric and kept among a very small elite group of people. It's a shared understanding that the developers in the system and various other people should really participate and continue with it as well. So when it comes to architecture, we all struggle to create architecture. But why should we really evolve architecture? Now let's think about this for a minute. In a project timeline, in your observation, when do you think architecture is actually created? A quick response. When do they create it? In the beginning. A lot of times in the beginning. Sometimes even before the beginning, right? We are told what the architecture is and we kind of get started on it. Let's think about that for a minute, if you will. So if this is the timeline, in a lot of projects, architecture is created right there in the beginning, as you can see. But I think most of us can agree that when it comes to a project, we start on a project, and this is kind of a very crude curve of our knowledge curve. In the beginning, we don't have a clue what we are doing, honestly. And we pretend that we do, but we really don't. And then towards about 50 to 60% of the project, things begin to make sense. Now let's put these two together. We all can agree that architecture is extremely important. And what is so important, we're going to do when we have the least understanding of what the project is about. And what is that called? It's called predictively irrational, isn't it? Because it makes absolutely no sense to do something very important when we have the least understanding of what we really are trying to do. And so by definition, the way we do this is a high risk. So it's extremely important for us to be able to evolve the architecture as time goes on. What if we'd say in the first about 3 to 6 sprints, depending on the project size, of course, we're going to take the time to evolve the architecture. But why don't we normally do that? One of the reasons for that is courage or the lack thereof. If you are playing an architect role in a company and you are told to create an architecture, and if you don't create an architecture, then why are you there? So a lot of times, companies will hire you and say, let's create an architecture, and we work so hard to create an architecture, we eagerly, but it takes an amount of courage to say, no, we are not going to create an architecture right now. We're going to maybe create a vision, we're going to create a draft, but we're going to evolve this over the next several sprints as and when we get a better understanding of the system, and we're going to move forward with it. So we have to really be able to postpone some of those and then create over time. That becomes very important. Now, there is a risk for not evolving architecture. And the risk of not evolving architecture is twofold. You probably have worked in companies where there are some very heavy-handed architects. These architects will tell you, this is how we're going to architect the system, this is how we're going to build it, and they will thrust that down on the teams. In fact, it's a bit frustrating when that happens. In some companies, I've noticed there are architects who once used to code, but they don't code anymore at all. The last time they did any serious coding was a very long time. I have a special name for those architects. Those architects are called as PowerPoint architects. And these architects are very dangerous people because they will draw pretty pictures, and before anything seriously gets done, they will either leave or wait until things begin to die, and then they would leave. So we don't want PowerPoint architects. What we really want is practicing architects. Architects who have a really good vision of the project. They can guide the development, but they can also get down and participate in various aspects of development. That becomes extremely important. And so what happens when PowerPoint architects lead the team and they tell you this is what we're going to do? Well, there are two things that typically happens as a risk on these projects. The one option in these projects is the team quietly says, you know what, that's not my job, it's beyond my pay grade, I'm going to follow whatever you, architect, tell me to do, and they just soldier through and develop the code based on the architecture. And when they do this, the architecture becomes irrelevant to the realities of the project, because as the requirements change and requirements evolve, the architecture says something, but the reality demands something else. And as a result, the product becomes quite irrelevant over time. And when we realize that it has done this, it becomes extremely hard and expensive and time-consuming to really make changes to the system, and that begins to follow a very slow death pattern from there. Or alternately, another thing I've also noticed, the team, the developers are extremely smart. They know not to mess with the PowerPoint architects. So what they do is they quietly sit down and start writing code based on the realities of the project. The architect, of course, is so busy they never look at the code, so they don't have a clue what's actually happening in the code. In this case, of course, when the architect comes around, they stare at the wall and look at the diagrams on the wall and say how cool this is. And when the architect leaves, they kind of go back to coding their own way, in which case the architecture that was created has no relevance to the practicality of the application as well. In both cases, we have not really achieved the goal of the architecture, which is kind of really sad. But of course, we want to evolve the architecture, but let's not be naive about it. There is risk in evolving architecture as well. What is one of the risks in evolving architecture? Well, one of the risks in evolving architecture is, what if the architecture does not support the changing requirements for the application as the application evolves? We always have this extreme fear in our minds. What if we are working on a project and we are into the 7th sprint, and suddenly there is a requirement that comes up and our architecture will not support it, and it becomes completely disruptive, and we have to spend the next 3 months re-architecting and doing stuff, and who's going to take the blame for it becomes the real concern. So how do we deal with it? So to understand how we can minimize that risk, I'm going to talk about maybe 2 different kinds of requirement changes we often face on projects. So when it comes to requirement changes, we can say there are maybe 2 ways to look at it. One is, I'm going to say known requirements. And these are typically backlogs that we are working on in projects. And then, of course, I'm going to say surprise requirements. I'll talk about what these 2 things mean in just a few minutes. So when it comes to known requirements, Typically on your project, you have a project backlog. You have a sprint backlog. You have a release backlog. Well, these backlog of requirements usually are defined in the beginning of the project. Sure, a lot of things in these will evolve. We'll get to know more details about it, but we would have identified the major things that we really want to do for this particular application. We have identified them at a very high coarse-grained level detail. Those are not completely total unknowns. The finer-grained details are really unknown, but we kind of know which direction we are going to head and what are the things we're going to do. Now, in these cases, one of the things that really frustrates me when I look at projects is they say they are agile, and then they say they are going to be really responding to change. But unfortunately, some people think agile development is very different from what in reality it is. So in terms of this, if you are going to take requirements, and sometimes you go to the team and say, hey, we're going to start a sprint in about a week. What are the requirements for the sprint? And they will sadly tell you, don't worry about it. We are agile. We'll figure this out. This makes absolutely no sense. Agile doesn't mean we will ignore the reality and be blind about it. So what we really need to do is maybe look at the requirements we have at our hands, and maybe we will start prioritizing it. Let's say we have a story 1 and story 2 and story 3 and so on. Now, we could be really wrong about a lot of these things, but the goal is not to be right, but the goal is to do as much as we can at this point. So what if we start putting together maybe a value of, let's say, 1 to 10, but the first one is based on the value or the business value of this particular story. So the business value of the story, and then the second one is the architectural impact of this particular story. And maybe we can start putting maybe values to this. This one is a very high value from the business point of view, and this is going to cause a lot of trouble for us if we ignore architecturally. Maybe this story has maybe 8 as a business value, but maybe it has a really low impact architecturally. And maybe this one has a value of 10, maybe this has a value of 7 architecturally, and we could go off and put these crude numbers together. And then what does these tell us? This tells us that not all stories are really equal. There are some stories which are extremely valuable. Other stories are, hey, would be nice to have them. And then, of course, some stories will have maybe things that will impact the architecture a lot. Other stories may have a minimum impact on the architecture. But what we want to start with on a project is we want to start working on those stories that have a very high business value and will have the utmost architectural impact. And as the project goes along towards the end, I want to do the things that are least valuable and the least impactful. But there is one consequence of taking this approach, though. The V word, or the so-called velocity. And I have to tell you, I really hate the word velocity. And the reason I hate velocity is, velocity says, how fast can you go? I care a lot about not the speed at which I go, but I also want to know that I'm going in the right direction for the right reasons. So if I want to show a really high velocity, I will take pretty useless things that are really easy to do. If you show me a real high velocity in the beginning, I get very nervous, because the time your velocity really matters is when you're done with a lot of things and you're getting towards the end. That's when I want the real speed. If you show me a really good speed in the beginning, that means you're going to slow down halfway through, and I don't even know how much time you're going to take after that point. That's a very high risk for me. So if you take this approach, you might be really a bit slow in the beginning, but because you're doing the hard things and most valuable things in the beginning, you will start gaining speed towards the middle and the end, which is what you really want to do. So don't just get convinced about velocity. That maybe is a really wrong thing to look at. So if we go this route, we can begin to really start addressing, and there will be fewer of those things that we cannot handle, because by the time we get to the 7th sprint, we have done what's the most important already, and anything that's left is really not that important. On the other hand, what if we have a surprise requirement? Your team of maybe marketing people and business people are in an industry trade conference, and they're sitting there and listening to what a competition is doing, and they make a frantic call to your office and say, we're doomed. I just saw that these guys are working on a feature, and we never ever thought of it. Oh my gosh, if we don't implement this particular feature, we might as well go home. And those are the surprise features. We never thought of them, and how are we going to handle it? Well, here's the deal, though. If you're working on a very traditional waterfall approach where you take all the requirements in the beginning and plan for all of it, the surprise requirements don't come to you and say, are you guys waterfall? Oh, yeah, we are. Well, then I won't bother you. We're going to only hit you on the head if you're agile. It doesn't say that. Surprise requirements are going to be surprised no matter what kind of project you work on. But the point really here is, if you take a minimalistic solution to your approach, then it becomes a lot more easier to accommodate change in requirements than if we go overboard and over-engineer solutions. So the practices we talk about will help us a little bit to see how we can address some of these requirements. The other thing I want to really talk about is, when it comes to design, so we can help ease some of these pains by prioritizing the stories based on the value, business value, and the architectural impact as well. But I have one other thing that really frustrates me quite a bit on projects that call themselves as agile. And that is, when you look at projects over time, what we have seen is organizations would perform a lot of effort in creating architecture and design. And we, in the waterfall days, we used to call them as big upfront design. Now, the problem with big upfront design, we all felt it. We all know what the problem is. So what is wrong with waterfall approach? We did big upfront design. The good news is now we are all agile, which means we don't have to do any design, right? Well, I think that's really foolish. If you really think about big upfront design, what is the real bad word over there? The bad word is not design. In fact, I would even argue the bad words there is not even upfront. The real bad word there is the B word, the big. So it's not that I don't want an upfront design. It is the big upfront design that's really bad. And I get frustrated when I see projects that are calling themselves agile, and they go with no design at all, and they kind of hack their way through in the projects. And that usually ends up with a disaster and a chaos in the end. But instead, what I want to do is, I want to entertain what I would like to call as enough upfront design. And that enough is knowing how much you want to explore the design and having the wisdom not to go any deeper than you really need to. So one of the things I encourage my teams to do is, even before the sprint starts, I want to tease out some requirements. I want to tease out, for the sprint, I want to tease out some high-level architectural ideas for the sprint before we get down to the code. And having this enough design before the sprint helps us a great deal not to walk into the dark blindly, but to really ask the questions, what are we really going to do? What are our scope? What are our major design goals and ideas? Sure, a lot of these things will change as time goes on, and that's perfectly okay to change, but I don't want to ignore those details when I get started on projects. I'm a huge fan of doing enough upfront design rather than not doing any design at all. It's more like as a pendulum, if you think about it. One extreme is big upfront design, and the other extreme is no design at all, and I think neither of those is actually a right thing to do. What we want is a fairly reasonable balance right in between, where we do enough design to explore things, and then so we can use that knowledge as we go through the sprints. So I talked about the reasons to do and the risk to do these things, but I want to switch over to talking about some of the practices we can follow to create an evolutionary design. Now, one of the key things to keep in mind is, remember that the only constant is change. Our ability to change is probably one of the most important things to really think about it. Now, one of the biggest challenges for us is we use words like performance, we use words like scale, And I often ask the question, do you know what your real needs are? I mean, for all practical purposes, I'll give you an example. I was working with a client where we were developing a code for a particular feature, and as we were developing it, I had made 2 calls to a database. And immediately a developer said, oh my gosh, you're making 2 calls to database. I said, is that really that bad right now? He said, well, of course, you should never make 2 calls to a database. And I said, well, why shouldn't we make 2 calls to the database? And he said, because the performance will be really poor. And I said, how poor is going to be the performance? And then I asked him, with all respect, how many users do you have in your system? And don't get me wrong, it's a very valuable application. It is a noble application. It is serving real valuable users. But then he said, well, right now we have about 200 users, and maybe we'll have maybe 1,000 users at the max. And then I said, well, you clearly are not Google. You clearly are not Netflix. Then why do you care about performance more than what you really need? And we tend to put these things to extreme, where we say, my gosh, performance is the most important thing. No, it is really not. Performance is important. Scale is important. But what is even more important is understand what our business requirements really are. And if you really look at products, the products that really aim for scale and performance are really the big losers, because you don't even know what your application is going to be, whether it's even going to be successful or not. And pivoting when you see the reality and the ability to change those is probably the most important thing compared to planning for the worst in the beginning or the best in the beginning. So one of the ways we can actually help in this process is to keep things really simple. Now, unfortunately, the word simple is overused and abused in a lot of ways. A lot of us don't really know what simple means, even though we can all agree we got to really keep things really simple. So we definitely want to avoid unnecessary moving parts in applications. Code that is very cohesive can become a lot more simpler. Code that has fewer coupling can be simpler. Code that actually focuses on the real problem and solves real problem can be very simple as well than trying to solve perceived extensibility. We don't even have a clue what that really is about. So we definitely want to strive for keeping things simple. There are a few principles we can follow along the way to make the code really simple. For example, one such approach is the so-called the DRI principle, don't repeat yourself. By removing duplication in code and duplication in responsibilities across the system, we can keep the code dry, and in that process, we can make it a lot more simpler. Another thing that can be very helpful in keeping things simple is to focus on the so-called single responsibility principle. To ask of each and every different module in the system and ask, what is the primary responsibility of this particular module of code? And having that code focus on that primary responsibility can keep this code very simple as well. But one of the things to keep in mind is to be able to refactor code almost continuously. There are some developers who feel that they get one chance to write code. And I think that's really one of the worst situations to be in. Our capability of writing code correctly and of good quality is actually pretty darn low, more than what we actually begin to accept and realize. So refactoring code is extremely important. Now, Frederick Brooks said a good 40 years ago maybe that go ahead and write a software system, and when you're done writing, throw it away. And now you have a chance of actually building a more appropriate application. Now, don't try to say this to the boss, right? Don't go to the boss and say, boss, I figured out how to do good software. When we finish writing, we're going to throw it away. And then we're going to start over. That's the easiest way to get fired. But does it mean that Brooks is actually wrong? Well, the sad part is he is absolutely correct. Well, if he's so correct, but if I cannot really throw away the project I've done, what gives? What do I do? Well, here's the beautiful thing. You don't have to throw away your project entirely when you build it. But what if we write a piece of code this morning, and once we write it, we maybe throw it away and rewrite just that part alone? And in my opinion, the most difficult thing and most courageous thing for a programmer to do is to throw away their own code. And honestly, that's not easy for me, because as a developer, I want to make sure the time and effort I put in is valuable and is used, and I will try to defend my code and keep it. But over time, I've realized the opposite. As an example, I was on a 16-hour flight, and I decided to implement a particular feature on this flight. 16 hours is a really nice quiet time to sit and work with no distraction from the internet. And when I got into the airplane, I came up with a really initial good design that I thought it was at that time. And I started writing the code, write test, write code. And it took me almost that 15 hours to write it. And the feature was done. I had this working. And when my flight landed, I came to a grim realization that my code and my design totally sucks. And when I got to the airport, from a hotel from the airport, that first 5 minutes were the most difficult time, because I check into the hotel, and in front of me is my computer with that code I had written in the airplane, and there's a devil and angel next to me. The devil says, "Great job, keep it." And the angel says, "Go on, Venkat, have the courage, delete the suckish code, start over." And then after the struggle, I took the courage to completely delete it. It was gone from the face of earth, and it was it was like, wow, that feels so good, I got rid of it. Now, this time around, it only took me 3 hours to rewrite it. And the reason it took me only 3 hours is all the discovery I had to go through, all the things I didn't know before, all the things I explored, those were no longer unknowns. They are knowns in my head. And this time it was a lot more easier to rewrite it. But when I finished it, I felt the design was a lot better than what I had originally had. And to be able to do it, and I'm beginning to really develop that courage more and more as time goes on, the courage to actually delete parts of the code I wrote, application I wrote, and to start rewriting them. And to be able to refactor. So generally I say, refactor other people's code, rewrite your own code. So as you are working with it, continuously improve existing code, but the new code you are writing, go ahead and rewrite it and see if you can do better. And the beautiful thing about this is you don't have to tell the boss you are doing this. And that way you don't have to have a permission to make your own code better as you do this in the very incremental manner, if you will. It's a good idea to have a second opinion. A fellow developer is always a good thing to have so that we don't go off on a tangent to do stuff that is not really useful. So having a good technical person to kind of review what we do is definitely a good thing. The next thing I want to talk about here, which is pretty essential, is this idea of reversibility. I can't say that anything is more valuable than this, because asking this question is extremely important. So what is reversibility? So reversibility is the ability to back out of our design decisions. And this is extremely critical for us to be able to survive in this world. So when it comes to making design decisions, we want to make decisions along the way. Hey, what library are you going to use? What framework are you going to use? How are you going to design this? What algorithm do you want to use for this particular problem? We make so many decisions every single day when we work with code. Now, when you sit down to make a decision, ask the question, how reversible is this particular decision? If it is easy to reverse out of the decision, then go ahead and make it somewhat lightly. That's okay. If it is very expensive to almost impossible to reverse out of the decision, then don't be so eager to make the decision. Maybe you want to think about this a little bit more. For example, I decide to use this XYZ XML parser. Hey, you know what? I'm going to use this library to do XML parsing. Tomorrow, if I decide I don't want to use that particular parser, I can change my code to use a different parser, not a big deal. So using a library is a fairly easy design decision. There's a difference between a library and a framework. You use a library. A framework grows around you. And if I pick a framework and 3 months from now or 6 months from now I say, nah, wrong decision, I should change my framework, there's a short answer for it, you're screwed, right? And that becomes extremely hard to deal with. So I would be a lot more inclined to choose libraries, but I'm a lot more reluctant to choose frameworks. Same thing with language decisions. How many times we decide programming languages to use, and unfortunately, a lot of times it becomes an emotional decision. I was at a client site once, and 99% of the company was using one particular language. I won't mention the language here, it doesn't matter. But they were using one language. There were pockets in the company quietly using a different language. So I went to the VP of R&D and I said, hey, why do these people use this one language throughout your company? I'm just curious. I'm not challenging your decision. I'm just curious. And he said, oh, the answer is very simple. About 7 years ago, there was a small group of people who really, really liked this language. So they started posing questions in a way, the answer will be this language, and they convinced the entire company to use this language, which is really a sad decision if you really think about it, because changing the programming language on a project is extremely difficult. It's one of the hardest reversible decisions we could actually make. So we should always ask the question, am I making decisions that are easily reversible? If a decision is reversible, go ahead and make it. If a decision is really hard to reverse, slow down and think about it and be sure that you're actually making the very right decision. And of course, keep in mind, not everything is reversible, but there's a cost for reversibility also. If you want to make things reversible, just because it can be done reversible doesn't mean we should make it reversible. Also, just because something is reversible doesn't mean that we really made it reversible. I'll give you 2 examples of this. Hey, is using a database a reversible idea? Oh, yeah, of course. There are libraries and APIs, JDBC, ODBC, whatever terms you want to put on top of it. You can use those and you can reverse out the database. And you say, I'm so glad you said that because we got a lot of stored procedures. You're like, get out of here. Well, what could have been reversible suddenly became non-reversible right now because of decisions we made. On the same token, I once went to a company, and when I went there, they said, we are using, and they used a database name I have never, ever heard of. And I said, whoa, I'm sorry, really, pardon my ignorance, but I've never heard of this database. And they were so proud when I asked that question, and they proudly said, it's a database we created. I said, I don't understand what you mean you created. Like there are databases you could actually use, right? No. We want to have complete control over this database, so we created it. And then I asked them, who is maintaining this database you have created? And he points to me a floor of 40 developers, and those people are just employed to keep this database up and running. It's like, dude, you could just go download a database and use it. And they said, well, we want to have every control over this. Well, there's a very high price for doing it as well. So we got to be very careful about decisions we make along the way. The last responsible moment is a very critical practice we need to follow when it comes to doing evolutionary design and architecture. Well, the last responsible moment simply says, do not make a decision until you can no longer postpone it. Don't confuse last responsible moment with procrastination. Procrastination is where we have not done something we should have already done. A last responsible moment is doing it earlier is not necessary. We can wait until a later time. I'll share with you one experience that I had recently about it. I was building an application. I had 6 months to release this product in its first version. And when I started on the very first day, I wanted to decide what database I should use for the product. Now, nobody in the right mind would use SQLite to develop applications. But in this particular case, using SQLite would give me the absolute agility because it's a file, I can blow it away, I can change the schema 1,000 times in a day. I know very little at this time. So I decided to use SQLite for this application. And I went for a first, nearly 5 months, I never used a real database, and I built with it. And at the end of about 5 months, about a month away to go into production, I was getting pretty nervous. And I told myself, this is my last responsible moment. I better make a decision. There were two reasons I postponed the decision. The first reason is to get the agility to be able to make changes to my schema and be able to evolve without being held down. And the second reason was, in all honesty, this application has to run on cloud. And I did not know where I'm going to deploy. And I didn't know what kind of facilities were available on the cloud, what kind of pricing I would get for the databases. So I really had to clear these unknowns. And over these 4 months to 5 months, I had found all those details. Those decisions were made. I know exactly what I'm going to deploy. So it was much easier to make this decision. And on that fateful day when I decided to do, I remember very clearly how it went. I came to work, I turned off the phone, I said, I don't want to be disturbed by anybody. It's a very important change I'm going to make. And I had all the tests passing, and I made changes to downloaded the database I'm going to use, made changes to the configuration, and I reran all the tests. And all of a sudden, 3 tests that I had immediately failed. And that moment is called the moment of panic. I'm like, oh my gosh, what do I do? Things don't work. And I'm saying, calm down, Venkat. And I did a little search, and I found out what the problem was. It was a problem with a particular data format. I made a change to it, rolled back to the old database, made sure all the tests were passing, rolled forward to the configuration to use the database I want to use. All the tests passed, and I checked in. Where I'm getting to with this is, the last responsible moment is very important, but there's a reason why a lot of companies and teams don't get to do it. Imagine you are in a team where you have people doing manual testing. And when you have teams doing manual testing, you have made decisions along the way. And when your team has done manual testing, they've had all these months to test your application manually. And you come towards the end, and you suddenly make a very drastic design decision. And who is going to now have the time to test all of this? And if things begin to fail, your testers who do manual testing can immediately point finger and say, these guys made a change too late in the game. We never had time to test. It's their fault. And you cannot point to them and say, you guys didn't test it because they're doing it manually. Clearly, they won't have time to do it. So a lot of times, we want to make decisions early because that minimizes our risk from having to test it from the early on. But if I have automated testing, I don't have to really do things too early because that feedback loop is pretty quick. And in other words, if your organization doesn't have a culture of having significant automated testing, then last responsible moment is a disaster. On the other hand, if they have a fairly good culture of creating automated tests, you can very bravely postpone decisions and change them because you have an ability to get feedback very quickly later on as well. So a lot of these features just don't work, practices don't work in isolation. They also require other practices to be in place as well. The next one I want to talk about is the Yagna Principle. I do have to admit this is one of my favorite principles to follow, which stands for you aren't going to need it. And oftentimes, I put a little why towards the very end just to ease the pain of my developers. You aren't going to need it. They get angry. But if I say you aren't going to need it yet, they are so happy. They say, okay, I don't need it now. Can I come back and look at it tomorrow? That's fine, that's fine. We can talk about it tomorrow, and keep saying the same thing until you release the product. But the point really is, we implement so many things in projects with the perceived thing that, oh, we need this. But I always question this. Do we really need it? Or can we postpone it until we can no longer postpone it? You know, how many times we create a hierarchy of classes because we need this hierarchy? One of the things I always surprises me is when developers sit down and they create interfaces without ever creating a class. And I go to them and say, why are you creating interface? And they look at me like, because we need it. Like, why do we need it? We think we need it. Why can't we just grow into it and see if we really need it? I can tell you how many times I do a lot of code reviews, and how many times I would highlight code and tell a developer, delete it, and they will protest it. You know, it's extremely hard to remove code you have written. It is so easy to remove code you never wrote. And that's one of the reasons I want to really keep it at the bay. And if I don't need it, I don't want to write it. And postponing it until I have a very clear picture that I absolutely need this one. This comes to various other things. Point in case, I was pairing with a developer. And I'm as guilty about this as anybody else is. I was pairing with a developer, and we were writing tests and writing code. And in the middle of writing code, I said, wait, we have to handle this special case, right? And I started writing code for the special case. My wonderful developer next to me elbowed me and said, excuse me, Venkat, are you not supposed to not implement that little error checking? You should get the code focused on what we are working right now. Then you have to come and write a test for that error condition, and then come back and it's like, yeah, I know this stuff. Don't preach to me. I'm a human too. I kind of tried to sneak it in, but you're right. So I kind of removed that part, got the code working, all the test passing. Then we come in to add the test for the error condition, and as soon as I write the test for it, to both of our surprises, the test actually passed. And he said, hey, were you so quick that when I turned this way, you sneaked in and put the code again? He said, no. I didn't write the code. I'm really puzzled why the code worked. And when we looked into it, that's when we realized the underlying library we were using was already handling that error case. And here I was trying to implement an extra code to do the checking. How naive of me. And had I written that code, that's a code I have to maintain, which was totally unnecessary. And we see this a lot in a lot of things we do. But what about extensibility, though? Don't we have to really care about it? Well, Ralph Johnson put this in a really nice way. He says, we build abstractions, we build infrastructures of code, we build hierarchy of code with the perception that we need to really make the code extensible. And when the time comes to really extend the code, we realize what we really need to provide is not what we had anticipated. And as a result, we have to now implement these extra code, but the code we already wrote actually makes it really hard for us to extend. So by postponing that until a much later time, we can actually do a lot better with it in projects. So this minimalistic design is something I really, really care about. This brings up to this concept of parsimony. I'm a huge fan of parsimony. And parsimony is really aiming for minimalistic design. Sometimes people who work with me get really angry with me because I would constantly say, hey, we don't need to write this. Let's keep it minimum. We don't need to write this, keep it minimum. And by keeping it minimum, hands down, the code you did not write has the fewest bugs in it. Hands down, the code you did not write is the one you don't have to maintain in the future. So I want to keep it extremely minimum. I once worked on a client project where when I went in, I saw they had interfaces. And in all honesty, I said to myself, I love these people. They're using interfaces. That means the code is extensible. I like it. Then I started looking into other parts of code, and they had a lot of abstract factories and factories being created. And I said, I love design patterns too. I'm so happy that they are creating these things. And once all these was over, I started looking, and I found something absolutely weird. I found that they had two kinds of interfaces in the application. The first kind of interface were interfaces which had exactly one class implementing it in the entire system. And the other second category of interfaces were no classes ever implemented it. I was, at this point, very curious. I went to the team and said, forgive me, but I'm very curious. I see these ghost interfaces nobody ever implements, and there are these interfaces that are only one implementation of what's going on. And the very first response, I'm sure you've heard this in teams, the first response they said is, Venkat, you should know, nobody who wrote that code is working in the company anymore. This is to just relieve ourselves of responsibilities, right? And then these guys wanted to create a framework, and they ran out of time and money, and so they kind of left what they had behind, and we don't even really bother about a lot of things they did. We're just focusing on getting the product implemented. And you see this bloat in the application, so big code size, and what is the purpose of it? The other problem I often see this is, just work on this, try this around. It's really funny. You're in a conference, you're in a place where you're meeting, strangers who are in your own field. Just sit next to somebody and ask them, hey, what are you working on? And just quietly listen to what they say. They will tell you, I work on a very large application. And why do they say I work on a very large application? Because nobody wants to tell you, I work on a small application, it works really well, it makes revenue, it provides value, and we go home on time. Nobody ever says that. Instead, they say, I work on a very large application. You say, whoa, how large is it? It's 7 million lines of code. And you're like, what does it do? It keeps me at work and it gives me ulcer. No, not to you. But what does it do for the business? We don't know yet. And this is the pride we take, right? We want to build monsters because we feel that we are really valuable, because we go to work every day and say, I fought that monster. And when you come home, you can tell those stories, war stories to your children. I'll tell you what mom did at work today, son. And then you're trying to tell all these stories, right? Well, what if we build applications that are minimalistic, small, easy to maintain, and we can actually go home and have quality of life as well? So minimalism is extremely important to me. I don't want to build monsters because monsters then eat me alive. I don't want to be eaten by monsters. I want to just create applications I can actually maintain. This leads to triangulation. Ken Beck talks about triangulation, where he says, don't build hierarchies, interfaces, and classes first. You instead go ahead and build a class, make it work. Then when you need something, create another class which is very, very similar. And then once you do, extract what's common into a base, maybe an interface or an abstract base class. You may say, oh my gosh, wait a minute, you just said earlier duplication is a bad idea, but if I have a class already, and if I'm creating another class which is very similar, isn't that duplication? Well, duplication is evil, but only if others see it. So just go ahead and do it, and then refactor it before it gets visible, really, and then you can really get the benefit that your interfaces actually are very practical. So I'm a huge fan of triangulation. This is one of the reasons I tell my developers, don't create interfaces first. Go ahead and implement the feature with one class. Wait until you see a different requirement that requires variations of it. Go ahead and build it with duplication. Make sure it's exactly what we want. And now let's refactor to remove the duplication and bring in the interface we need. And that seems to be really helpful. Real quick, Postel's law says, be very generous about what you receive and be very conservative about what you send. This was created as part of the TCP/IP protocol, but we can do this, and this is especially so important today in the world of microservices, if you will. Because if you are very rigid in what you receive, you are going to become very brittle when the world around us changes. But if you're very generous about what you receive, if you don't do very thorough error checking and format checking and say, hey, you know what, I only care about this part, I am not going to focus on other parts I'm not really concerned about, then when your message moves through your distributed system, through microservices, your microservice doesn't get brittle because of changes in other parts of the application. So Postel's law is a very important law to follow. It has been around for a long time, but in the world we live in of microservices, this is actually even more important. And finally, what about reuse? Well, this is one of the things people really strive to do, is they begin to try to reuse before they actually find out what to do to use. And when we try to strive for reuse before we actually use, we end up creating something that is not even usable. If you look at a lot of reusable frameworks, those reusable frameworks were created based on very active repeated use and continuous refactoring from it. So it's very important for us to focus on use first and then eventually create something reusable. And the last thing I will tell you is, I really, really fear using libraries and frameworks. I do really, because when you look at the dependency graph of applications, it's just horrible. Recently, I came across a team, and we were programming in JavaScript, and I asked him how things are, and he said, well, you know what, a lot of our tests which we used to run, we don't run them anymore. I said, how sad your automated tests don't run anymore, but why? He said, because a lot of them broke. I said, why did they break? Well, because all these libraries we use, we upgraded them, and a lot of tests broke, and we don't have time to fix it. I said, how many libraries are you using? And without missing a beat, very casually he said, oh, about 150 libraries. I said, are you serious? He opens a grunt file and shows me dependencies to 150. Then I looked at him and said, why are you using 150 libraries? And he looked at me and said, because we found them. And this is infatuation. And when I used to be a young developer, we did not have internet. I'm not saying the world was better back then, but what I'm saying is, we didn't have internet. We couldn't download libraries. If I wanted a library, I got a request for it. I got to pay for it. And then it arrives on an 8mm tape drive. And I have to take the tape drive and install it. You don't want to install products using a tape drive, believe me. And so we were very, very selective in what we brought into applications. Today, You go to lunch and come back, there's 7 more libraries installed on your project because the guy who didn't go to lunch is finding things and saying, oh, I found this tool, isn't this beautiful? And we have a bloat of libraries, and it's really hard to maintain. The other thing I will also share with you is a very, very difficult story. I worked on a project where we're really focused on delivering a product within 6 months. We were very actively working on it. And we were really keen on hiring other developers. And so we were looking actively to hire somebody. And we found one person who was extremely good after a lot of search. And when we found this person has been developing his own framework. So my boss at the time came to me and said, hey, what do you think of this guy? I said, don't waste time talking to me. Really amazing. Go hire him now. And he said, what do you think of the framework he's been developing? I said, that's an awesome framework. I've never seen anything like that. That's awesome too. But anyway, go hire him. He said, what do you think of us using his framework? I said, oh, wait. Drop your weapon. Don't do this. We need to focus on delivering the product we have right now. Don't mess with this framework. You don't need it. And then he would say things like, what about this feature? Well, you never mentioned that you need a feature like this before. Why do you care? Well, 2 weeks went by. And he came to me and said, I got a good news for you. We hired this guy. I said, I couldn't be happier because I think we're going to have fun. I'm going to learn from this guy as well. What a great time. He said, oh, by the way, as part of the hiring contract, we are committed to use his framework. And I thought he was joking first. And then I said, are you serious? Absolutely. And then I said, I'm quitting. And I walked out right there at the moment. And 6 months, they were supposed to finish in 6 months. 18 months later, I get a call saying, we haven't finished it yet, can you come and help us? And when I asked them what was going on, they said they spent 18 months fine-tuning the framework because it quite doesn't work with the application. It's a framework we didn't even know exist on that day I quit. And the point really is, we get infatuated with libraries and framework, and it becomes really hard. I am not infatuated to use frameworks or libraries. I really care about delivering value, delivering products. And so the frameworks and libraries I use must really solve real problems for me. It has to really deliver value, and I would really take more time to examine and see if this is what I should really be using. And only if I feel very compelled, I would start using libraries, because usually it ends up really complicating things more than I can manage. So to summarize, we talked about the reasons to create evolutionary architecture. We talked about the risk of not creating it. We talked about the risk of creating it as well. And then we talked about a few principles we can consider in terms of how we can make the evolution really affordable and possible for us to do. I hope that was useful. Thank you.